Let me know when I should get started.
Yeah, you're good to go.
Okay. Hello, everyone. Thank you for coming. Welcome to Longhorn PHP. It is delightful to be back on the conference circuit again after a hard couple of years. For those who don't remember me from before the pandemic, my name is Larry Garfield. I go by Crell online. I'm now over on Mastodon. I have left BirdChan, I guess it's called now. I'm a staff engineer for LegalZoom, also a member of the PHP Fig core committee, general purpose pedant, and I've written a couple of books. So that's enough about me. So we're talking about serialization today, but all right, what is serialization? Serialization, of course, is the process of putting cornflakes in milk. Now that we've gotten the obvious joke out of the way, we can continue. In computing, serialization is the process of translating data structures or object state into a format that can be stored, transmitted, and reconstructed later. This is any time data is moving into or out of your application, it is getting serialized in some fashion. Technically, I would say even SQL is a form of serialization. However, come on, note that for many complex objects, this process is not straightforward. Understatement of the year. Now, PHP has a lot of different ways that we can do serialization built in, and some of them are even useful. You can take pretty much any value except the resources and certain types of system objects and throw it into the serialize and unserialized methods, and that will dump the value out in a proprietary PHP-specific string format that is useful for absolutely nothing except these functions. For objects, you can control how that serialization works. We've had the sleep and wake up magic methods that have been around forever, and they're kind of badly designed. You shouldn't use them. The serializable interface was added in 5.1 and deprecated in 8.1 because it's badly designed. You shouldn't use it. There's the serialized and unserialized magic methods. Those are good. You can actually use those. There's a little-known feature called var export. Who's worked with var export? Oh, decent number of people. So var export will take a PHP value and generate the code that will reproduce it. But if it's an object, you can't really do that. So it relies on the class having a magic method called setState that will get data passed into it, and then you reconstruct the object yourself. It's a hard-coded static factory, essentially. There's also JSON serializable, which is very niche, and it's not symmetric. It works in exactly one place for sending data out through JSON, which is, it's rare that I only want to do that. So that's not very useful either. So the useful options are serialize, unserialize, and var export. So which one should you use? Well, it occurred to me that var export should be faster, because with setState, you're just running raw code. It's already been opcached and everything. And turns out, when I did extensive benchmarks on it, no, actually. Serialize and unserialize are really, really fast. The performance difference between them, using setState is slightly faster, but you can't actually measure it unless you're serializing thousands of objects, or deserializing thousands of objects. So pretty much, if you want to do built-in serialization, that's what you got. Here's how they work. Say we have an object, and we can implement the magic serialize method, which will return an array. What's in that array? Entirely up to us. And that array is just the properties that will get put into the serialized form down here. And that's, if you can read that, that's what PHP's native serialized form looks like. Then when you deserialize it, that data will get passed to an unserialized method. If you don't specify these, serialize will just grab all of the properties, and deserialize or unserialize will just shove values back onto the properties. If you want to do something other than that, then you can implement these methods and do pretty much anything you want, including really dumb things like calling out to globals. If you need to reconnect objects like this, that means you're doing it wrong, because there's no way to get that kind of data without going through a global of some kind. And also note a security issue here. You should specify what classes you're allowed to unserialize to. Otherwise, This is external data that is a potential security threat, and you could deserialize the classes you don't expect. There are known attack vectors that way. Okay, so how do we make, I said you shouldn't play around with globals, so what makes good serialization? How can we make our system serialization friendly to make it fast, make it stable, make it performant, make it logically sound? And there's one key concept that does that. You need to separate your logic from your data. This is the oldest slide I have. I've been using it since 2011. Thank you for giving me the opportunity to use it again. What do we mean by that? If you have an object that is in your DI container, you do not serialize it, period. That's a service. You have no business serializing that. If you have an object that references something in the container, guess what? You can't serialize that because you have no way to unserialize it without messing around with globals to get those services back. If you have a value object, or some people call these DTOs or something like that, totally fine. Those are great to serialize because they're just data. There's no connection to logic or state or system configuration. It's just data. That's good. If you have an entity in your system and you're using a data mapper model, then those should serialize fine in almost all cases. If you're using active record, well, guess what? You can't safely serialize and unserialize. I know a lot of you use frameworks that are built on active record. This is one of the reasons why you should not be using active record. And note that this applies to all serialization formats. This is true for PHP's built-in serialization, as well as any other format you're going to serialize to. So JSON, YAML, XML, TOML, whatever. Speaking of those other systems, what if you want to serialize to something that is not PHP's built-in proprietary syntax? Well, then you're pretty much on your own. PHP doesn't really offer anything to support that. So this is kind of the state of things in 2021 when I worked at Typo3. It's a popular German CMS, open source, and it's powered by gigantic 20-year-old designed global configuration arrays. Everything in Typo3 is driven by these gigantic multi-layered configuration arrays that are accessed globally. It's a disaster. And I set out to try and fix it by turning those config arrays into objects that we could then type check, handle defaults, and all that kind of fun stuff. But the catch was those array structures had never been refactored because that's a BC break, because that's a raw array. This is why you shouldn't use raw arrays as an API. So I needed a way to be able to convert those arrays into objects so that they could be used without, but changing their structure on the way. So what I needed was to mutate the data on import. I needed dynamic type maps. Type maps are, if you have a property that is an interface, and there could be multiple objects of that type, okay, which object are we dealing with? Which object type are we dealing with? That's type maps. Some systems call them class discriminators, same thing. We had cases where we had a string that was comma-separated values that was then used in the system as a string of comma-separated values, and everywhere that used it had to explode it itself. Yikes. And of course, it had to be fast. And now I'm a firm believer in the principle, don't solve a problem, build a tool to solve the problem, and then use that tool. Now, I looked at these sets of requirements and said, you know what? This sounds an awful lot like serialization, or rather deserialization specifically. So is there a serialization library that I can just use and do what I need to with these giant arrays? So I looked at what is generally the most widely used serialization framework in PHP from Symfony. On the plus side, it's widely used, and it is very flexible. On the other hand, it could not handle changing the structure of the data as it was being imported or exported. Some systems can, Symfony can't. It only supports static type maps. So if you want to specify, under these conditions, this data gets imported as this class or this class, that has to be hard-coded. And there's no way to make that dynamic. I tried. And its architecture is actually really complex. Who's worked with Symfony Serializer raw, not part of the Symfony framework? It's kind of tricky to set up. And it became clear after 2 weeks of trying, I did my due diligence and tried to make it work, but it became clear after 2 weeks, this is not going to work for what we need. So, all right, time to write one. All right, so if I'm going to write a deserialization framework that's going to do all this stuff, I should look at what's come before. So I looked at Rust's Serde library, mainly because it is by far the most well-respected serialization library of any language. It's frequently cited by people as the best thing about Rust is how stupid easy serialization is in Rust because of this library. So, all right, this seems like a good thing to study. The end result that I ended up with is not a direct port of Rust Serde, but it does draw heavily on it for inspiration and architectural design, adapted for the fact that it's PHP. So the end result was a trio of libraries. One that's just a bunch of functional programming utilities that are used by the other two. We're not going to talk about that again here. Don't have time. One is a way of handling attributes in PHP in a much more robust way that provides a ton of features on top of core attributes. Not going to talk about that in detail. See me after if you'd like. And then Serde itself, which is the serialization library. All of these were built, the project was started during the 8.1 beta cycle. So this was some of the first code written for PHP 8.1. So how does one do deserialization? Well, let's look at a super simple case. There's lots of super simple cases like this available on GitHub. I'm going to show you mine because I'm the one talking in the presentation. I actually built this long after everything else we're going to show. This is just to show the concept. So env-mapper is a way to populate environment variables into a class object. And the code for it looks like a lot. It's actually really small. It's just 2 slides. We start with, provide a input source of data, such as some array. If you don't specify one, we grab the environment. Then we use reflection to get the properties off that class. And then for each one of those properties, if the incoming data has a matching value, then all right, we normalize the type, because in an environment variable, everything is a string, and assign that to an internal array. If not, we check and see if there's a default value in the constructor of that object. And if so, we can use that. And if not, that's an error. Once we have that array, then we have this simple closure, which we then bind to an object. So we can use reflection to create a new instance of an object, bypassing its constructor. So we just get the raw object with no setup, and then we call the populator method here using env as the object that it's on. So this lets us just on the fly say, OK, inside populator, this means env. And it'll run in private scope. So you can access and modify any property you want. And then we return the object when we're done. What does this show? What can we learn from just this simple example? Deserialization is driven by the class definition. Not the incoming data, it's driven by the PHP class. Type information, defaults, all of this information is driven by the class. And also say reflection, it's not free, but it's pretty fast. Reflection gets a bad rap for being horribly slow. If you're smart with it, it's not that slow. These are all going to be important when we do a larger version. I'm going to run out of water. This also shows us our first cool PHP trick. We've got a couple of these, that you can very easily bypass visibility using closures. You can just have this simple function and then bind it to an object, and now that reader can read any private property you want, or the same populator we saw before, simplified version, you can use to populate an object, and you can completely ignore if it's private, if it's read-only, anything like that. Please don't do this unless you're writing an ORM or a serialization library. But know that it's there. Another thing that we kind of glazed over there, using enums as error codes. What this library does is define a prop value enum with a single value in it. And then get default value can return either the value or some prop value instance. Why? Well, the real case uses mixed here, but if we want to have a there isn't one value, well, we can't use empty string because that could be the default value. We can't use 0 because that could be a legal value. We can't use null because that could be a legal value. So we need something completely outside of our possible values to indicate there's no value at all. And null doesn't work for that because null keeps getting used as a value. So instead, we use an enum for it. Much more about this in an article here, links later, about this technique. I find it very helpful. I use it a lot in these libraries. Is this what enums were intended for? No. Is it a completely valid use of enums? Yes. So let's have a look at Serde then. How does Serde itself work? So pretty simple. You create an instance of Serde and have some data class here. You don't need to do anything fancy to it. Any class will work. And then you can serialize it to a format and deserialize it from that format to some class. Bada boom, bada ding. It works for JSON, YAML, PHP arrays, CSV, streaming JSON, and streaming CSV for export only at the moment. And you can customize per object type how the serialization works. So you can override individual classes very easily. It comes with a number of formats out of the box. You can easily add more. I have some in the pipeline that I'm working on. XML is hard, but I want to do that eventually. And if you are defining serialize and unserialize, that will get used. It'll just defer to those. But you don't have to. If you want to have more control over what happens, attributes control everything. So, can we read that? We have this field attribute that you can put on a property, and that controls the serialization behavior. In this case, we're saying first name will get serialized to call me, and then deserialized from a property called call me down here. The last name, we're going to pass through a renaming pattern. So some logic that's going to change what last name turns into. For deserialization, you can say, all right, deserialize from a value called employer, or at this value instead. This is great if you're changing your format, you want to still support old versions. You say, all right, any of these old names get used. And you can also say, just skip this property entirely. One thing to note here, this cases camel case, that's an enum. Because enums can implement interfaces. So there's a renaming strategy interface, and then a enum with standard case folding, and then a method that will do the case folding. And I'm skipping over the logic here, but this actually works really well for common cases. You can also implement your own objects that implement interface, or the renaming strategy interface. That's fine. But for the built-in stuff and a couple of others, it's really easy. Defaults. This is when deserializing. You can say, you can specify an explicit default. So if you try to deserialize a empty value, just an empty JSON object or an empty YAML string or whatever, then location will get the value hidden. Name will get the value anonymous. Age, we're explicitly saying don't use a default, which means it'll stay uninitialized. Does this mean the object is now invalid? That's up to your business logic. It's up to you if that is what you want to happen. But we can also say, if there's no job field, then that's an error. Just throw an exception, we're done, because that's not OK. And you can actually control this at the class level as well, so apply to all of the properties. We also need to differentiate between sequences and dictionaries. PHP arrays are the language's original sin because it conflates lists and maps into a single data structure, which nothing else does and makes life so difficult when you're talking to anything that's not PHP, like serializing to JSON. So, the system will take a good guess if you don't specify, but you really should flag an array property as, in this case, it's a sequence of products. And this is a dictionary of strings to tags. And that'll get serialized out something vaguely like this. So items here becomes an array, and tags becomes a JSON object with key values. You do more with that. So to note here as well, we're specifying the type. So that's important for deserialization, but also validation. I mentioned before imploding. Any of these fields can do extra stuff on them. So the field property is optional. If you don't specify it, it still works. In this case, we're saying this is a sequence, and we want to serialize it by imploding it with a comma. And then when deserializing it, we'll explode on the comma. For a dictionary field, we can say implode on this and join individual entries with that. So we get 5, 6, 7, and hey, look, HTML syntax, all built in. This is the one that I really needed for typo 3, flattening. That's the name that I believe Rust Serde uses for this. And the idea is, if you have a pagination object here, so we've got a result class, we've got a pagination object, then that has just some values of its own. That's useful in PHP, but not so useful in JSON. So we say, all right, this field, flatten it. And then the properties in that object just get moved up a level into the output. And it works the other way around as well. You can deserialize this value back into this object. As I said, Rust Serde can do this, Symfony cannot. You can get more advanced with that. In this case, we have two flattened properties, product type and nested pagination. Nested pagination itself has another object inside it, pagination state. And then we have an array of product types and so on. So we've got nested objects here. We also have a flattened array for other stuff. Because in typo 3, many of our array structures had other stuff that's not defined. It's just opened for extensions to figure out what they want to do. Oh, God. That will serialize to and deserialize from those, this value. So we have total and limit are coming from nested pagination. The second one here is coming from pagination state. These are from product type, which also gets flattened. And these last are just whatever was in that other array. And that means we can also take this data and deserialize it back into a structured object that has a better structure than the mess we're given by someone else's API. And include, we don't know what this other stuff is. Type maps, mentioned these before. Say we have a book type. We've got different kinds of book, and we're referencing a book. We've got an array of books. OK, serializing this is fine, but when we deserialize it, how do we know what type of book this is supposed to be? Well, that's where type maps come in. And it's another attribute. So the simplest way to do it is you specify a class name type map and give it a key. And then the actual class that this is, when you serialize it, will get written out as that type. And then when you deserialize, it will strip this value off and use that as the class name. Really simple, not necessarily they're really useful because it's a PHP class name, but really simple. More typically, you can create a static type map where you just specify a mapping list yourself. If it's that should be paper book, sorry, then that says paper. If it's a digital book, it gets called an ebook. And so we get ebook in our output. But you can also specify this map on the interface itself. That's something attribute utils gives us. We can traverse the class structure to find the right map to use. But let's say your data is not statically defined at code time. It's an interface. It could be any number of classes. Or it's going to depend on plugins installed in your system. OK, so we can have a dynamic type map. Any object can implement the type map interface. And then it has two methods, one going one way, one going the other way. And then we create an instance of that. You can wire this up in your DI container. And then when you create Serde, you actually pass it for a product type, use this type map. What's this logic doing? I don't know. It's up to you. Symfony Serializer cannot do this. This is something we needed. I'm not even sure if Rust Serde is able to do this one. I haven't seen it, but I could be wrong. It does do a ton. Streaming. This was not something type with we needed. I just felt like adding it. Serde can stream to JSON and CSV. Specifically, it also handled traversable objects. So if you have a property that is typed traversable, or it's an iterator or iterator aggregate or something like that, then it'll get treated like any other object. And just whatever properties it has inside can get serialized. If you have a property that is an iterable, then PHP doesn't know if it's an object or an array, which means we treat it like an array, which means if it's generating values lazily, cool, we're going to serialize those values lazily. And if we connect lazy generation to lazy output, we can now stream values all the way through at constant memory. Let's have a look at a simple example. We can add in an extra formatter for CSV streams. Give it some kind of file resource, could be any stream resource, and then pass it in as an init. And it will write out whatever this data is to a CSV stream as it goes. CSV has some specific rules around the structure of the object, because CSV itself is a very restricted format. But this way you can produce data, however, and write it out straight to the browser or to a file or wherever. For a more complex example, so we have a product list that we're going to serialize, and we have a sequence of products that is iterable, and we're going to have a generator here, note the yield, that's going to lazily produce product objects. This is a trivial example. You wouldn't do it this way for something this simple, but imagine that creating a product is more involved than this. Then we have our product list object, which has a property that is generator. And we say, all right, we're going to format this out to JSON, to PHP output, and go. And it will now lazily load a product object, write it to JSON to the output. Load a product object, write it as JSON to the output. Load it, and so on. So yeah, this is a great way to generate large files. Last major feature I want to talk about is scopes. Who's used serialization groups in Symfony Serializer? One person? OK. Same basic idea, but this is done generically. So this works. This is in attribute utils. So the same logic can be used in any library that's using attributes if you want. In this case, the idea behind scopes is you say there's multiple versions of an attribute that's defining how the serialization works. And under different conditions, I want to use a different one, a different set. So in this case, we have a user object. And if we call it without specifying a scope, then we get just the username, because this is excluded and this is excluded. If we say use the admin scope, then we get this value. This is still excluded, but this admin scoped version of field will override this version. And OK, this version doesn't say to exclude it, so that'll get used. Make sense? And deserialization works just the same. It's completely symmetric. One nice way of using this, versioning. Say we're adapting our API. Then we're going to say, all right, skip fields by default. So if there's nothing specified on them, we won't use them at all for serialization or deserialization. Then opt in our ID field. Stock will never get used. Fancy widget will get used. And in the scope legacy, we want to use a serialized name of label instead of name. The price field is only used in the new system scope, and the legacy price is only used in the legacy scope with this funky other name. So we're called no scope. Then we get just the ID and the name, because those are the only ones that have a unscoped field. If we call it with the legacy scope, then we get ID, because there's no override. We get name, but renamed. And we get legacy price renamed to cost, and this one gets ignored. And if we call it with a new system scope, then we get the ID, the label, and this price. Yeah?
So you're saying we could assign, in the context of an API versioning use case,
Yep.
we could assign specific API versions to scopes?
Yep. Yeah. You realize what this could do, and you're like, oh. So also you can use this for translation. If you have different language versions, you're labeling things, different language version of each one, it'll get a different label. That's not so much for serialization, but for the attribute utils library. All right. So let's look inside how this behemoth works. It's actually, I think, surprisingly straightforward, to be perfectly honest. It's stream-based. Not that it's using PHP streams, but it does not have a complete intermediate representation. The way like Symfony Serializer and a lot of other serializers work by first taking whatever it is and turning it into a giant PHP array, and then serializing that, and then deserializing to a PHP array, and then decomposing that back to an object. That's not how Serde works. However, an individual format can use an intermediary representation if it wants to. That's optional. That's why like the CSV formatter or JSON formatter don't have an IR. They don't have a big array at first, or in the middle. But the normal JSON one does build up a big array, so I can just call JSON encode at the end of the day. But that is up to the formatter to do. Everything is driven by attributes. That is the way you control things. And I am working on a way in attribute utils to stub out attributes that get populated from something other than attributes. Stay tuned for that. There are importers and exporters, which put data onto an object and pull data off an object, and then connect to a formatter and a deformatter, which are responsible for turning those values into whatever the format is and back. So there's no big array in the middle. There's a fixed set of methods that the importers and exporters call on the deformatters and the formatters. Try saying that 5 times fast. I'm amazed I got through that. And you can implement both of these on the same object if it's simple. In many cases it is, but you don't have to. And then it's just a recursive call all the way down. The overall appearance of Serde itself is like this. You have the Serde object, Serde common, and it will initialize the formatter, which gives it some setup value. Then it creates a serializer object, which it passes all of its configuration and dependencies to. And that just loops over the properties of the object you're serializing. And for each one, calls the right exporter, which is per type, which could be PHP type, or it could be class type. And then calls a type-specific write method on the formatter, which will in turn recursively call back to the serializer for sub-values in arrays or objects. So it's recursion all the way down. Deserialization, basically the same thing, just the order that these interact in is slightly different, but it's the same basic loop idea. Another thing I want to call out there is our next cool PHP trick. And I don't have a formal name for this pattern yet. I've started doing it a lot. For the moment, it's internal execution object. I'm open to suggestions. But if we have a complex process that's going to need both of these parameters and these dependencies, well, the ugly way is to say, all right, call run, and run's going to call some other method, which calls some other method, and each time we have to pass through these values to each one of those. And then if you have to do something recursively, oh God. Instead, when you call run with these objects, we create an inner object, and my class name is wrong, sorry, and pass it all the dependencies here and those parameters. Those are all now stored statically on the, not statically, read-only on the runner object and available to all of these methods, which can also then be recursive. And you can pass this object itself around because everything is read-only. So you don't need to pass values in every time. You can easily make it immutable, so it's safe to use public properties if you want to. And you can pass, if thing runner is going to call dep A, you can pass thing runner to dep A to give it context for that particular call, and it carries all of that context with you. Takes a bit to wrap your brain around that one. It took me a while to figure it out too. But I found this to be a really powerful approach for dealing with more complex tasks. That means everything here is functionally pure. And it also means you don't need to do dependency injection on every individual piece. Dep A and dep B can get their dependencies via thing runner. Setup for it, this is Serde itself. It's, you extend Serde common is just a common configuration, extends a base class. And you can use Serde common yourself or write your own, or there's one that has no configuration. You can just configure everything directly. Take your pick. And also note, excluding exception definitions, there are 2 places in the entire code base where the word extends appears. And this is one of them. This object does almost nothing. It just passes off to another object. It's just for configuration. You can make a modern PHP library that is fully functionally pure and uses almost no extension and is purely composition. Yes, it can be done. This is proof. I also want to call out this line because we need the class analyzer from attribute utils to pull in all the attribute information, but nowhere have I passed it in any of these examples. That's because I'm just creating it on the fly in the constructor if you don't specify it. And specifically, I'm even caching it. So request something multiple times, it gets cached. Default dependencies are really, really easy now in modern PHP. This isn't even a trick. This is just a language feature as of 8.1, where you can specify a default value that is an object, as long as that object can be statically created, meaning that there's no runtime values for it. So very useful when a dependency is a utility, and you don't want, and it doesn't have its own dependencies, so you're not going to have a long chain of dependencies there, like in this case. This makes testing much easier because I can just create a new instance of Serde common and poke at it. I don't need to go to as much work for setup. I don't need to mock things. It makes one-off uses a lot easier. So if you want to use this in just a throwaway script, it's one new line. You don't need to create 15 wrapper objects the way you do with some systems. In production, you should still wire everything up with your DI container. This is a convenience, but not best practice in general. So all those places where you have a default null logger, you can now just do that inline and forget about it. OK, so this took me several months to design and build all of these pieces. And I was showing everyone at Typo 3 what I was doing along the way. The CEO knew about it. And after I finished, they decided, nah, we like global arrays, never mind. But fortunately, it was an open source company, so I held the copyright for it, and it's already on GitHub, so it didn't go to waste. So you all get it now. And out of spite, I went ahead and built the config system that I was trying to build for Typo 3 anyway. And it took me less than 4 hours to build, because everything else is handled by serialization. Serialization is not just writing to a web response or to a cache on disk. Serialization is configuration. Let's have a look at how that works. We have 2 YAML files, let's say, for our config files, called editor settings in different directories. One of them has 2 properties, one of them has 1. We have an editor settings class that has properties, some of them with defaults. And then create a config loader and feed it. We want to read from a YAML file in this directory and a YAML file in whatever our current environment directory is. and then we can wrap that into a cache. This uses just PHP serialize and unserialize, because that is the fastest way to do it. And then we load editor settings. And that will use that class and the name to go look up these files, squish them together in this order, take that array, and pass that off to Serde to deserialize, and then cache the result. Which means we can do anything Serde can do with our configuration. Let's have a look at a more complex example. Dashboard settings. We have a components array. So we have a name field and a components array. The components array is a dictionary, so it's keyed by string, and it's showing components, which is an interface. And there's a type map that probably want to make this dynamic, but for now it can be static. We have different types of components, which have identifiers for them. We're going to flatten it, so we don't need to put all of this under an extra level in YAML. And I'm going to override the file name that gets used to just dashboard. If you don't specify, and now it'll look for dashboard.any of the supported file formats. You can pick what those are. If you don't specify, then it just does a stir replace on the class name, which may be sufficient for what you want. It may not. Up to you. Now we can define a couple of components which have some properties. They're backed by an enum. OK, nothing fancy here. And now we have a common dashboard config with all of these different components defined flattened. So get rid of all that extra indentation. They have a type, which is going to indicate what type of component it is, and different properties depending on which type they are. And then the admin dashboard gets an extra property on it. And then we configure this directory and the append, and so on, and just load the dashboard settings. And we get back a read-only public property value object with our complete configuration that has all of the properties defined, typed, with default values guaranteed to be there. And if a default value is missing, you can configure the system to catch that before it gets to your code. Also, left and right handles enums just fine. Those get turned into the enum objects. How do we use it? Well, we have some service in our system, and we're just going to declare that as a dependency. Declare dashboard settings. And then we can do stuff with it. We can guarantee our data is valid at this point, because the type system says so. You want to test it? Great. You create a new dashboard settings instance yourself. You don't need to write anything to disk. You don't need to set up demo files. You just make the object, pass it in, and do your testing. For actual production, the syntax is going to vary depending on which DI container you're using, but you just say, all right, when dashboard settings is requested, go get the config loader and ask it for dashboard settings. Boom. No need for mocking library. Everything auto-wires. You get guaranteed type safety, guaranteed default values, and the data is all read-only, so you can just access properties directly and not have them change out from under you. If you want to put methods on the objects as well, knock yourself out. It works fine, but you don't have to. Whew. That's a lot. What have we learned? var export is great for code generating arrays. If you're doing code generation and dumping out a giant configuration array, var export is great for that. You should not use it for anything else. If you have a value that you're just using internally for your application, not internally to your company, internally to your application, then serialize and unserialize are going to be your fastest option. Excuse me, just like if you're writing something to a cache or generating data that you're going to read a lot and so on, this works fine. For anything above that, Serde is your most robust and I would say fastest option. It's surprisingly performant, and I know there's some additional performance tuning I can do in there. Only ever serialize clean value objects. Do not try to serialize things that have a dependency on your database or your repository or anything else like that. You're in for a world of pain. I was there when Drupal tried to do that. World of pain. Attributes are awesome. PHP attributes are a fantastic feature made better by the right tooling. If you take nothing else away from this talk, PHP is the schema. Modern PHP's type system is strong enough that it can serve as your schema definition. You do not need to define a custom YAML syntax. You don't need to go look up JSON schema. You just use PHP classes, and that is your data schema. And it works pretty damn well. Because modern PHP is a really nice language. I had fun writing this. What the language will do for you is fantastic if you approach it in the right way. So links to resources. The slides are linked from LinkedIn already, and I dropped them in Discord earlier. These are all the libraries that we talked about today. These are the articles that I recommend for follow-ups. And thank you very much. And amazingly enough, I do have a couple minutes for questions, if anyone has.
So, a question from the library maintainer perspective. So you started as something that was supposed to work for type of 3. You threw in some additional features that they might not need, and on your way, you discovered that type of 3 doesn't need it. So how do you see the future in the scope of this library? Like it's powerful, it's complex, it may have influence on the ones who uses it. And like, how do you see whether or not you will accept a given feature? How are you going to approach the deprecation?
Oh, I've only got 4 minutes left. So yeah, to repeat for the video, now that this library is out, but it's not being funded by Typo3 anymore, now what? Well, just hit stable release at this conference. This is the inaugural launch of the library. That said, it's been out for 2 years and has users, I know, because I've gotten bug reports. And we've been able to fix them. Some people have offered patches. Some I've taken, some I haven't. At this point, play it by ear. Try to be a good community citizen about it. But at the same time, I'm well aware of the burnout risk. So if it starts getting huge traction, I will probably look into some kind of sponsorship for it earlier rather than later. Because if people are relying on it, then we need to make sure it remains supported, and I need to not die in the process. Those are both important. So that's the short answer. Other questions?
So without going into too much detail, why did Typo3 not use this versus global arrays?
Legacy. Change is hard.
Stubbornness. I tried. They hired me to do modernization efforts. They wanted to improve the system and pay off code debt. And so I started trying to design systems that would let us do that gradually. And leadership decided they didn't want to change after all. So that's the short version. And admittedly, they've got 20 years invested in giant global arrays. Other questions?
Is there anything interested in like protocol buffers in terms of serialization?
I have not looked into protocol buffers or any of the binary formats. In concept, there's no reason those couldn't work.
Right.
One of the main reasons I did the streaming versions of JSON and CSV is to prove that I could. And I think I actually did those after I left Typo3. But yeah, if you want to do something like protocol buffers or gRPC, I think it's called, or other things like that, it should be straightforward to do, assuming the format itself is straightforward. I haven't tried, but patches welcome.
Okay.
Have you worked with them?
Not directly. My company does a lot of it, and I think I look a little bit at it. My one concern would be that protocol buffer is very oriented towards like your schema is defined externally to your code, and so that would be kind of where you have any conflicts between your generated code versus your defined schema, how that gets resolved.
Yeah, I would have to look into that. I haven't played with protocol buffers.
So conceivably, could we serialize something in Serde and deserialize it in Rust, I guess?
If you're going through JSON in the middle, absolutely. It's just JSON. Or any kind of web API. You're putting out JSON, you're receiving JSON. You're writing YAML, you're reading YAML, whatever. As long as the other end knows to read that serialization format, cool. I think I have time for one more question if anyone has. If not, we can call it there.
Not really a question, maybe it is. I can see this library being really useful for CSV imports and exports in the system.
Yeah.
Very aiming for that.
Streaming imports don't work. That's harder. Probably could be done for CSV. I haven't tried yet. But certainly for generating, yeah, there's examples in the docs already for doing exactly that. Yeah. All right. Thank you, everyone, for coming. Please remember to rate the session on LinkedIn. Joined in, LinkedIn too if you want. One of those ins. Slides are on joined in and in channel. I'm happy to answer questions throughout the rest of the conference if you have them. Go forth and write free software.